Hi everyone, hope you're doing well. This is a video for day 90, line of best fit. You can find these worksheets on my Weebly. So at this point, you already watched the Ed puzzle on how to construct a line of best fit, and I think it's a great Ed puzzle, and I always show it in class because it shows exactly what you have to do visually before we even go over it, so it's perfect. All right, so for this lesson, you will need a ruler or a straight edge, so make sure you have that handy. All right, when data is displayed with a scatter plot, it's often useful to attempt to represent that data with the equation of a straight line for purposes of predicting values that may not be displayed on the plot. Such a straight line is called a line of best fit, but it's also called a trend line. So these two things are the same exact thing. I'm going to be interchanging them in this worksheet. Make sure you know this for your quiz in the future. So a line of best fit is a straight line that best represents the data on a scatter plot. This line may pass through some of the points, none of the points, or all of them. I think the video said that too. So some, none, or all. So that's very important. So you've been seeing me draw lines, kind of through these graphs and scatter plots that I've been doing, but now we're going to actually show you the real way you're supposed to do this. So this is your scatter plot. This is your x-axis and your y-axis, and then you have your title. You see the dots, again, they're not connected, and you have your line of best fit going through. Notice here that there's no arrow, and you should know, because this is real life, no arrow, because you cannot have a negative, it's talking about time or money. Time or money. So keep all these, real life things in the back of your head while we're doing this. All right, so next page, let's start constructing. All right, so this says sketch a trend line for each scatter plot. Again, you know that trend line is the same exact thing as line of best fits. So you want to draw a line that best resembles what your graph looks like, okay? And then you learned from the video that you want to try to make it in the middle of the dots as possible. You don't want to make it above, not below, in the middle as possible. It could go through one, none, or all of them. So you just kind of try your best to, and that's why it's called best fit, your best to figure out where it should go. So definitely make sure you're using a pencil, because then what I do is I kind of just count 1, 2, 3, 4, 5, 6 on that side. 1, 2, 3, 4, 5, 6, 7. That's not bad at all. 6 on one side, 7 on the other. That's not bad at all. That's pretty good. Notice I didn't even pay attention to that dot over here at all. Remember, and you saw in the video, that's called your outlier. And you notice that I knew I was going to make a line that goes in this direction because it has positive association or positive correlation. So I always want to draw my line where my correlation is. Like, I don't want to draw it this way negative because I don't have my dots going that way. So it has to be in the middle, and it has to match your correlation or association. All right, number 2. This one to me looks like it's negative. So I'm going to try and get these somewhere. I don't know. Let's try there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Oh, that's not good at all. All right, so I'm going to erase. I'm going to try again. I'm going to make this go a little bit higher this time. A little bit higher. So now I have 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's not good either. All right, so a little bit lower. Third time's a charm. So maybe like right in between those other two. So just you try your best. You try to have it somewhere in the middle. Like, you don't want to have like 10 dots on top and only one on the bottom. That's not going to be good. So just try your best. Again, line of best fits. This is going to be a negative association. And our last one to me looks like it's going to be positive. So I want to have it somewhere in the middle. It looks a little high. Okay. So we try again, maybe more like this. So you just keep trying, try your best, keep trying until you get what you think looks like it's going to be in the middle. Okay, and I want to point out one thing over here. If you notice, these dots are all together. We learned that word the other day, and that was cluster. That was cluster. All right, consider each pair of identical scatter plots Circle the letter of the plot that shows the better trend line. Explain your choice. So which one looks like, according to the video that you saw, which one looks better? And that's going to be this one here. And that's because you have more dots. Let me show you this. So you have more, so the line is more in the middle of the dots. The line is more in the middle of the dots, okay? Notice that there's no arrows here or here because you can't have a negative number of heaters sold. And then also notice that you have these here. And again, those were your breaks. That just allows you to skip some numbers. All right, so let's look at the example. This one, definitely. And again, that's because the line is more in the middle of the dots. So for number 1, it's choice A, and for number 2, it's choice B. All right, next page. Using a scatter plot to make predictions. Make a scatter plot of the data and draw a line of best fit. Then use the data to predict the exam grade of a student who studies 4 hours per week. So this is just an example that's already done for us, just to show you what we're going to be doing in the future. So you have these values, X and Y, hour study and exam grades, and they told you to plot it, what's already done for us. Draw your line of best fit, so somewhere in the middle. Notice this is your outlier, so don't pay any attention to that. Actually, it says it right here too. Ignore any outliers when drawing a line of best fit. And then what we're going to do, and you have this on your final exam as well, so it's good to know this. It wants us to know about 4. So basically, you're going to take your pencil and you're going to go up until you hit that line that you drew, wherever you drew it. And then you're going to go across until wherever it hits the Y. So that's around, I don't know, they say 78. That's going to be you predicting. So we're going to not only make these lines, but we're also going to use them to predict answers. All right, so the next page. For questions 1 to 4, write whether each scatter plot shows a positive, negative, or no association. If the scatter plot shows an association, draw a trend line and then make a prediction. So basically, we're taking everything we learned on the first 3 pages, putting it together, and we have here. All right, so notice these dots are all over the place. So that's going to be no association. So what you learned in the video, that if there's no association, you cannot make a line, and therefore you could not predict anything. All right, question number 2 is down here. This one, I guess, is positive. So try your best to get it in, oh, I don't know, maybe like this. To try, yep, that looks about good. Now, my line might be in a different place of yours, so our numbers for this prediction might be a little off, but they should be pretty close. So association is going to be positive. And now it wants us to predict when X is 1,000. So here's 1,000. So take your pencil, or you could take your ruler as well if you want to make it nice and straight. And then you're going to go up to the line. Okay. And then you're going to go across. So that exact place where it hits, you're going to go across. And it looks like mine's around 35. So yours should be somewhere close to mine, anywhere between like 30 and even 39, okay? Somewhere between there, and you'll get it right. All right, the next one looks like we have another positive one, positive slope. So let's see, maybe right here. Remember, I'm always drawing it in the middle in the same, I guess that's close enough. In the same direction as what your slope would be. So that's going to be positive. Okay, and this time they want when X is 600. So 600 between 500 and 750. So 600 maybe is like around here. Okay, so you can again use your ruler or just eyeball it. I'll eyeball this one. So go up and you go over. So it looks like it's between 20 and 30. A little bit closer to 30. So maybe I'm going to say 26 or 27. 26 or anywhere between, 22, 23 to 29. You should be somewhere close. Like you shouldn't be in the 40s. You shouldn't be in the 10s. So, the teens, but you should be somewhere close to what my number is. All right, last one on this page. Now it looks like that we have a negative slope. So that means I would have a negative association. So 1, 2, 1, 2 looks pretty good. Remember, again, association is the same thing as correlation, which is the same thing as relationship. They all mean the same exact thing. Okay, so association, correlation, and relationship. You have to be comfortable with all of those words together. All right, so now we're looking for 850. So 850 is like maybe like 100 past 750. So it's a little bit past that. All right, so if I go up, this one I'll use my ruler again to show you how you can use the ruler. So up, and then the exact point you hit that line, you want to go over, and it looks like I'm around, I don't know, 25, 26. So anything that's, you know, close enough to what I have. So 23, 24, 25, 26, 27, that's good. But again, no, nothing in the 30s and nothing in the teens. All right, next page. So on the previous page, we were just doing some predicting, and there's going to be some fancy words for predicting. So what we were just doing is something called interpolating. Interpolating. If you are looking for values that fall within the plotted values, you are interpolating. So what does that mean? That means this number here, I'll just use this, 600, was inside my domain, was inside my graph. Okay, over here, 1,000 was inside my graph. 850 was inside my graph. Now, if something's not inside the graph, that's called extrapolating. So interpolating inside, extrapolating extra outside. So if you're looking for values that fall outside the plotted values, you are extrapolating. Be careful when you're extrapolating. The farther away from the plotted values you go, the less reliable. So to show you on this page, I'll just use this example. Let's say I wanted you to tell me when x is 2,000. Okay, x is 2,000. Is 2,000 in between 0 and 1,000, or even a little more, maybe 1,500? Is 2,000 in between? No, it's outside. It'll be somewhere out here that's not plotted on the graph. What about, well, they're all up to 1,000. What about 3,000, 4,000, 5,000? None of those numbers are plotted in between those values. So that would be extrapolating outside. Okay, that's what we're going to practice with now, interpolating and extrapolating. So this number one, the scatter plot at the right shows the number of chapters in a book in relation to the number of typos found in the book. If you predict the number of typos that would occur in a book containing 12 chapters, you would be extrapolating. Okay, so I'm going to go to where it says chapters. Here's chapters. And I'm going to highlight number 12. Well, do you see 12? Is 12 there? No, 12 is out here on the outside. So which one meant outside? That was extrapolating. That was outside. Fancy words. Fancy, fancy. Number two, if you were asked to interpolate information from this graph, you would have to be careful to limit the number of chapters. Oh, okay, so our word is interpolate. So that's going to be inside. You're going to look for inside the plotted. So 2 and 8, yes, that's good. 1 and 9, well, that's even better because that's my beginning to my end. 2, 4, okay, so you want to pick the one that has all or shows all the plotted values. So your beginning is 1 and your end is 9. So you want to choose between 1 and 9. That's going to cover all of the values that are inside. All right, hopefully you're doing okay with this. Next page, there's kind of like a lot of little random things in this packet. Use the following information to answer questions 1 to 4. Joey kept track of the number of free throws that his team shot in practice and the percentage that they made in the next game. He displays his findings in the scatter plot below. Again, don't forget, this is bivariate. Bi meaning 2. There's 2 different things. Your number of free throws and your percentage in the next game. Remember, that's always comparing. All right, so what are we doing? Draw a trend line. And this is a real life question. So trend line, please remember, means line of best fit. Line of best fit. All right, so we want to make sure that we have our line follow our direction, so it definitely looks positive. And we want it to be so that it's somewhere in the middle of the dots. Oh boy, let's try here. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Yeah, that's pretty good. Nice job. All right, so I want to point out a couple things. I want to point out this bacon looking thingy. That again is called your break. Each worksheet shows it differently, and that means you can skip those numbers. I also want you to notice the way that I just drew this, okay? I didn't put any arrow over here at all, so no arrow. And that's real life. If you keep going this way, could you have a negative number of free throws? No. Could you have a negative percentage? No. And one other thing, and this is really weird, this doesn't really ever happen, but I didn't put an arrow here and I didn't keep going because I feel like percentage, you can't really have more than 100%. So no arrow and stop at 100. Cannot have more than 100%. So you could do it that way. If you wanted to, you could really extend it because we do teach it in the honors that there is something more than 100%. You know, 200% if you're doubling and things like that. So really whatever you want, I'm okay with, just as long as there's no arrows on this side, okay? So I'm going to erase this again. All right, does the trend line show a negative, positive, or no association? So we said ours is going to be positive. Does the trend line show a linear or nonlinear? So linear, remember, means line, and nonlinear means not a line. So does this look like a line? Does this look like these go in a curve? I definitely think that these are more linear. So I'm going to say linear. And number 4, a student takes 60 free throws during practice. Predict the free throw percentage that the student is likely to have during the next game. So 60 free throws, number of free throws. Okay, so we're going to interpolate. So 60 will be around here. And again, it's all really going to depend on where our lines are. So my line goes to here. I'm like right above it. So 61, 62%. Okay, if you made yours a little higher, you'd have a little higher. If you made it a little lower. But again, it should be pretty close to my value of 61. Okay, extrapolating or interpolating. So this 60 was inside my plotted values. So inside, interpolating. All right, hopefully you guys are doing okay. Got 2 more pages to go. The scatter plot shows the relationship between the weekly total sales and the number of different rug designs a rug store has. Based on this relationship, predict what the total sales will be when the store has 110 different rugs. All right, so the first thing we want to do is we want to make our line. Now, it does have to do with number of designs and total sales, so I will not be putting an arrow. Okay, where is half? Maybe middle is like here, maybe? And again, make sure you have no arrow on this side. This is definitely going to be positive correlation, meaning as the number of designs increases, so does the total sales. And we want 110. Is 110 inside? Yes, 110 would be right here. So that's inside my plotted values. So I'm going to go up and I'm going to go over. And I'm between 30 and 40, which is 35,000. So that's what your answer should be for number 1. Number 2, in the scatter plot, a line has been drawn to show the trend in a population of box turtles, I don't know what that is, over a period of 12 months. Estimate the population of box turtles after 9 months. So 9 months is my magic one I'm looking for. And that should have an arrow. All right, so what are we doing? So 9 months. So something was already drawn for us. So 9 months is inside my plotted value, so I know it's interpolating. So I'm going to go up. Don't go to the dot. Don't go to the dot. You have to go to the line. Okay, you have to go to the line. So it's a little higher than 10. So let's go like around 110. And if they ever make a really tricky one, they'll give you like a dot down here, not close to the line, and then they'll give you an answer choice of something like 80 because they want you to mess up. They want you to pick the dot, but don't pick the dot. You're going to go up to the line. All right, number 3. Carl graphed the data shown in the scatter plot and then drew a trend line. Why is a line not good for this data? So hopefully you can see that this data is really curved, so nonlinear, and linear does not represent nonlinear. So because the data is non-linear. You cannot, why is that not a good fit? You cannot draw a straight line. And a trend line is therefore not a good fit for the data. Not a good fit for the data. All right, and our last page, almost done. Last page. A straight line is a good model for a scatter plot. Well, this is what we just did on the page. If it was nonlinear, right, we just showed this here. If it was nonlinear, does a line represent it? No, so that is false. A trend line should always pass through at least 2 dots on a scatter plot. So that's going to be false. Remember from the beginning, we said it can go through some of them, none of them, or all of them. Some, none, or all. So this is going to be false. And please remember that these trend lines, that's also your line of best fit. LOBF, line of best fits. A trend line will never include a point that's an outlier, and that is true. Okay, if there is ever an outlier in your question, you basically just ignore it. Okay, you're just going to ignore it. All right, number 4, the scatter plot shows the number of times different popular movies were rented and the number of weeks since the release of each movie. So rentals of popular movies, weeks since the release, number of rentals. Okay, is the line drawn a good model? So think back to the video that you saw. Think about everything that we were talking about. Is that in the right place? Nope, no good. Not a good model. And why? What's wrong with this? Because the line is not in the middle of the dots. You should definitely be drawing it more in the middle of these dots somewhere. Okay. Again, notice that there's no arrows because you can't have a negative. So here and here, no arrows. Okay, no negative number of weeks and no negative number of rentals. All right, and then the last one, number 5, last one. The scatter plot shows the heights and weights of players on a professional basketball team. You want to draw a line of best fit for the data. Again, notice these breaks here. Every one we do kind of does it differently. So you want to draw it somewhere in the middle of the dots. So you want to have the same number of dots above and below. So 1, 2, 3, 4, 1, 2, 3, 4, 5. That's not bad. Pretty even, 4 and 5. Based on your line, would you expect a professional basketball player who is 77 inches tall, so 77 inches is right here, and by the way, that's interpolating. Would you expect them to weigh 140 pounds? Okay, so if I go up to my line, and then I go over, is that 100, whoa, no, is that 140 pounds? Nope, it's going to be approximately 200 and, I don't know, that's pretty low. Let's say 205 pounds. All right, hopefully this video helped and you understood everything. Please make sure that you do homework number 90 and that you're posting it on Google Classroom to get credit. All right, have a great day. Bye.